The first part of chapter 24, that is volume and surface area of solids, and in this part we are going to start with exercise 24a. So let's start with question number 1. Find the volume, the total surface area and the lateral surface area of the cuboid having length 24 cm, breadth 16 cm, height 7.5 cm. So volume. So the formula of volume of a cuboid is length into breadth into height. That is 24 multiplied by 16 multiplied by 7.5. That is 2880 centimeter cube. Total surface area is equal to 2 into length into breadth plus breadth into height plus height into length. So 2 into 24 into 16 plus 16 into 7.5 plus 7.5 into 24. So in the next step we'll have 2 into, so 24 multiplied by 16 is 384 plus 16 multiplied by 7.5 is 120 plus 7.5 multiplied by 24 is 180. So adding all the 384 plus 120 plus 180, that is 684. So 2 multiplied by 684, that is 1368 centimeter square. Next we have to find the lateral surface area. So lateral surface area of a cuboid equals to 2 into length plus breadth into height. So 2 into length is 24 plus breadth is 16 multiplied by height 7.5. So 2 into 24 plus 16 is 40 multiplied by 7.5. So on multiplying this 2 we'll get 300 in the next step. So 2 into 300 is equals to 600 centimeters square. Question number 2. Find the capacity of a rectangular cistern whose length is 6 meter, breadth is 2.5 meter and depth is 1.4 meter. Also find the area of the iron sheet required to make the cistern. Here L is equals to 6 meter, B is equals to 2.5 meter and H is equals to 1.4 meter. So capacity of the cistern means the volume of the cistern, that is length into breadth into height. So 6 into 2.5 into 1.4, that is 21 meter cube. Now in the question they have also asked us to find out the area of the iron sheet required to make the cistern. So area of the iron sheet required means the total surface area, that is 2 into length into breadth plus breadth into height plus height into length. So 2 into 6.26 multiplied by 2.5 plus 2.5 multiplied by 1.4 plus 1.4 multiplied by 6. So 2 into, so 6 multiplied by 2.5 is 15 plus 2.5 multiplied by 1.4 is 3.5 plus 1.4 into 6 is 8.4. So on adding this 3 we'll get 26.9 in the next step. So 2 into 26.9 is 53.8 meters square. Question number 4. How many planks, each measuring 5 meter by 24 centimeter by 10 centimeter, can be stored in a place 15 meter long, 4 meter wide and 60 centimeter deep? So we can see that the measurements are in meter and centimeter. So it's better if we convert all the measurements in a single, that is in a single term or in centimeters. Let us convert all the measurements in centimeters, so it will be easier for us to calculate. So volume of the place is equals to 15 meter into 4 meter into 60 centimeter. So 15 meter, converting 15 meter into centimeter is 15 into 100, so 1500 into 4 meter into 100, that is 400 centimeter, and this was already in centimeter, so into 60. So this is converted into centimeter cube. Volume of the plank, that is 5 meter into 24 centimeter into 10 centimeter. So there is only one in meter, so let us convert this 5 meter into centimeter. So 5 into 100 is 500 and the rest others are already in centimeter. So 500 into 24 into 10 centimeter cube. This is a cube, not a square. Since it's a volume, it's going to be centimeter cube. So number of planks is equals to volume of the place divided by the volume of a plank, that is 1500 into 400 into 60 divided by 500 into 24 into 10, that is 300 planks. Question number 5. A classroom is 10 meter long, 6.4 meter broad, and 5 meter high. If each student be given 1.6 meters square of the floor area, how many students can be accommodated in the room? How many cubic meters of air would each student get? So here L is equals to 10 meter, B is equals to 6.4 meter, and H is equals to 5 meter. Let us first find out the area of the floor of the room, that is length into breadth. So 10 into 6.4 is 64 meters square. Floor area occupied by each student as it is given in the question, that is 1.6 meters square. So how to find out that how many students were there in the room? That is number of students is equal to area of the floor divided by 1.6, that is area occupied by each student. So sorry, instead of writing 64, I have just written it here as 10 into 6.4, which is also 64. So you can write it here as 64 divided by 1.6. So on solving this, we'll get the number of students to be 40. Also, we have to find that how much of air is available to each student. So first we need to find out the volume of the room, that is length into breadth into height. So 10 into 6.4 into 5. So we are keeping it as it is because in the next step we are going to divide it. So air available to each student is equals to volume of the room divided by number of students. So 10 into 6.4 into 5 divided by 40. So on solving this, we'll get 8 meter cube as my answer. Moving to the next question, question number 6. Find the length of the longest pole that can be placed in a room 12 meter long, 8 meter broad, and 9 meter high. So you'll see that the length of a room, the longest length is its diagonal. Okay, so here we have to find out the diagonal of the room in order to find out the length of the longest pole. So here L is equals to 12 meter, B is equals to 8 meter, and H is equals to 9 meter. So length of the longest pole is equal to length of the diagonal, that is root over of L square plus B square plus H square. So root over of 12 square plus 8 square plus 9 square. So that is equal to root over of 144, that is 12 square, plus 8 square is 64, plus 9 square is 81. So on adding all these three, we'll get root over of 289, which is equals to 17 meter. Therefore, the length of the longest pole is 17 meter. So that's all for this part. Thank you for watching.